definite integration by substitution method. As here is a integral which contains composite term in which term of x is a g of x having derivative g dash x is multiplication of dash. As we put g of x is equal to and using its derivative g dash x ds dt put in integral, the value of integral does not change as this integral in term of x converted into term of t, as here f of t, and with respect to t we take the integration by using the relation dx and dt. Now check the integration, as this is a definite integration having the limits. As we know, given integral is in term of x, that means the a is a least value of x and b is a maximum or upper value of x. That means these limits are value of x. Now as we converted this integral in term of t, we have to change our limit. As that means we have to take new integral with values of t. For that we use this substitution. According to this substitution, corresponding to all limits mean as all limits are value of x, as x has a lower value a, so for that the value of t will be our next lower limit of new integral. So that we use the relation between x and t, as we put g of x is equal to, which is a relation between x and t. From this we get t is equal to g of a, as x is equal to a, and corresponding to upper limit, as old limit is a b, we get the value of t as g of b, and these new values are our limits. So in substitution, as we change the terms of x in t and take integration with respect to t and change the limits corresponding to all limits. For all limit, lower limit x is equal to a, we get the value of t as a g of a, which is our new lower limit, and x is equal to b is upper limit of old integration. Corresponding it, the value of t is a g of b. So new integration will be from new limit g of a to g of b f of t with respect to t, and we can evaluate the integration. In first example, as we observe, there is a term is a sine square x having derivative cos of x containing integral. So we put cos of sine of x as a t. So we using differentiating with respect to it, we get cos of x dx is equal to dt. Now remember, this is a substitution, but this is a substitution method in definite integration. So we have to change the limits, as the given limits are the values of x, and we are now going to convert this integral in term of new variable t. So we have to take new limits, new values of limits or values of new variable t according to substitution corresponding to all limits. For that, when all limit, that means value of x is equal to 0, we find the value of t. As relation between x and t is, we have sin x is equal to t, therefore here t is equal to sin 0, and sin 0 is always value is 0. Next, for x is equal to upper limit is given here pi by 2, therefore t is equal to again sin of pi by 2, and sin pi by 2 is always 1. So this means new limits, that means value of t are 0 and 1, but 0 is corresponding to all lower limit, so 0 is our lower limit, and 1 is for corresponding to old upper limit, so 1 is the upper limit. So new integration I from 0 to 1, take from 0 to 1. So we change the limits. Now we change the term of x as we did in substitution method. As the sin x is a t which is in denominator, so we take numerator as 1, and in denominator 4 is in subtraction, so we take 4 minus, and as sin x is equal to t, therefore sin square x will be t square, and cos x dx is a dt. Now take the simple integration, as here this is a radical form with the coefficient of t square is 1 and 4 is the square of 2. So we use the radical standard formula, as here subtraction is given. If addition is there in denominator in radical function, then its integration is in term of tan, otherwise it is in log with coefficient 1 upon 2a, as here a is a 2, that is radical is 2, so we take 1 upon 2 into 2 log of mod of, when a square minus x square is a fall, then we take addition in numerator of radical 2 plus here variable is a t divided by 2 minus t, that is subtraction of radical and variable, with here limit as 0 to 1. Now simplifying this, as 2 to 4 is a constant, so we take it outside. Now you can observe here, as we take the limits for new variable, so we can directly take here upper value and lower value of integration without resubstitution. So this process of changing the limit is necessary in substitution method. Remember this, for definite integration we change the limits in substitution methods according to substitution corresponding to our old limits. Okay, so in this example the upper limit is 1, so upper value is a log of, now 2 plus 1 3 divided by 2 minus 1 1, that is log of 3 is the upper value, minus lower value will be lower limit 0, in term log t is equal, by putting t is equal to 0 we get log of 2 plus 0 2 divided by 2 minus 0 2, that is log of 1. Now log of 1 is always 0, so lower value is 0, so we get the answer 1 by 4 log of 3. Next example, integration from 1 to a log of x divided by x. As here logarithmic term, that is differentiable term, is contained, so we use the method only. We can evaluate this integration by method only. As log of x has a derivative 1 upon x, which is in derivative in integration, so we use here putting method. So put log of x term of differentiable term as a t, and using its differentiation we evaluate the relation between dx and dt, as 1 upon x dx is a derivative of log of x into dx is equal to derivative of t is always t. Now we have to change the limits. Now here, when lower limit of x is 1, therefore t is equal to log of 1, and log of 1 is always 0, and upper limit of x is e, therefore value of t is a log of again e, log of e is always 1. So here the new limits is from 0 to 1, as old limits are 1 to e. So integration I is from 0 to 1, as log of x is numerator, so we put it as t, and remaining 1 upon x dx is a dt. Now this is a simple integration of t. T has the integration always t square by 2 with limit 0 to 1, as 2 in denominator is a constant, so we take outside bracket, and by putting upper limit we get the upper value. Actually power of variable having the value 1 is always 1, minus lower is a value is a 0, as lower limit is 0. So final answer is a 1 by 2. Next example, I is equal to from 0 to pi by 2 dx divided by 4 plus 5 cos x. As you can observe here, I put dx in numerator, as this is the integral of type 2. As you remember, this is the integral having denominator in form of linear term of cos of x. So by using standard substitution, that is tan of x by 2 is equal to t, we can evaluate the integration. In this type, we put value of cos of x in term of t is 1 minus t square divided by 1 plus t square, and dx is equal to 2 dt divided by 1 plus t square. This is a substitution. We have to change the limits also here. Now when x has a lower limit here 0, the value of t will be, actually a relation between x and t is the tan x by 2 is equal to t, therefore tan of 0 by 2, actually tan 0 by 2 is a tan 0, and tan 0 is a value have always value 0. Now upper limit of x is a pi by 2, so t is equal to tan pi by 2 divided by 2. Actually tan pi by 2 divided by 2 means tan pi by 4, and tan pi by 4 is a 1. So new limits are 0 to 1 corresponding to old limit 0 to pi by 2. Therefore integration I will become, as limit changes from 0 to 1, and we put the value of dx and cos of x in integral. In numerator we put the value of cos x, which is a 2 dt divided by 1 plus t square divided by 4 plus 5 into cos of x is a 1 minus t square divided by 1 plus t square. Now we make a simplification in integral by taking addition in denominator, as numerator is remain as it is, which is a 2 dt divided by 1 plus t square, and in denominator we make the addition by taking cross multiplication of denominator. So in first numerator 4 is multiplied by numerator 1 denominator 1 plus t square, and as denominator of first term is a 1, so in second term has a numerator 5 into bracket 1 minus t square with common denominator 1 plus t square. As you can observe, the numerator denominator has equal denominator, so it get cancelled, and we have with integration 0 to 1 limit in the numerator 2 dt, and in denominator simple bracket multiplication 4 is multiplied by this bracket, we get 4 plus 4t square, and 5 is multiplying this bracket, we get 5 minus 5t square. Now the simplification is over. As you can observe here, the numerator is containing constant 2, so we take it outside, and in integration 0 to 1 we get numerator as 1, as operator dt is in multiplication. Now as 4 plus 5 is 9, and term of t square 4t square plus minus 5t square is minus t square, as it is negative, so we take only first simplification of constant, that is 4 plus 5 9, and minus we get t square, as operator dt is in multiplication. As you can observe, this is again a radical form, we having subtraction in denominator of square term of t and constant, which is put in form of square, that is 3 square minus t square into dt. Now this form has an integral, as it is contains subtraction in term of log with coefficient 1 upon 2a, as a is here 3, so we get 1 upon 2 into 3 log of mod of, as this is a form of a square minus x square, so we take addition of radical and variable in numerator, that is 3 plus t here, and subtraction in denominator with limit 0 to 1. Now take the constant out of side, actually 2 get cancelled, and we get only 1 by 3, and now putting upper limit in logarithmic term, as t is equal to 1, we get log of 3 plus 1 4 divided by 3 minus 1 2, that is log of 4 by 2, that is 2, minus lower value will be lower limit as a 0, log of 3 plus 0 3 divided by 3 minus 0 3, that is 3 by 3 1, that is log 1. As you know, log 1 is always 0, so we get the answer 1 by 3 log of 2.